Hello everyone, now let's turn our attention to a new LeetCode problem. This is problem 207, course schedule. There are a total of 9 courses you have to take, labeled from 0 to non-course is -1. You are given an array prerequisite where prerequisites I equals A, I, B, I indicates that you must take course BI first if you want to take course A1, AI. For example, the time 01 indicates that to take course 0, that we will take course 1. You can prove if you continue our courses, otherwise false. There are a total of 9. Okay, let me read the problem to make sure I understand it. There are a total of 9 courses. You have to take, labeled from 0 to 9 courses -1. You are given an array prerequisite, I, prerequisite, where prerequisite I equals AIBI indicates that you must take BI first if you have to take course AI. Okay, so let me jot that down as our note. Let me just call it P. So 3 of I equals AI BI. And this means that you must take BI first if you want to take course AI. So this means that you want to take BI, then you take AI. I'm going to draw it as BI pointing to AI in here. For example, the pair 01 indicates you have to take course 0. If you want that to take course 0, you have to first take course 1, which will true if you can finish all courses, otherwise remain false. I'm not sure what it means by return true if you can finish all courses. Right now I don't have any much idea what it means by you cannot finish all courses. I'm not sure what cases that would be. And after finishing the study, I think all courses are reasonable that you could take all prerequisites and take the courses. But anyway, let's look at the example to have a better understanding. Example 1, we have non-courses 2. Let's just call it none 2, and then prerequisite. There are 0, 1. And then here, so there are 2 courses, and there are prerequisites 0, 1. That means you need to take course 1, then we take course 0. After that, we have satisfied all the courses that we need to take. If it is possible, then that is true. Example 2, courses is 2, and then prerequisite, there are 1, 0, and 0, 1. Alright, this is not reasonable because you need to take course from the first requirement. You need to take course 1, then so you need to take course 0, then you take course 1. But in the second requirement, prerequisite, it says that you need to take course 1, then you can take course 0. So there is a cycle there, obviously. So here it's not possible, and the prerequisite requirements doesn't make sense. Okay, so I think I got it what it means when we cannot take all the courses. But before we continue, I would like to clarify a few things. So first of all, may I know what are the range of num? Are they valid? So here it says that num courses is between 1 to 2000. And I think it's also good to clarify the length of the prerequisites, like how many are there. So it could be 0 to 5000. Okay. Requisite I dot length equals 2, I think that is implied in the question. AI PI is within the valid range, so I assume that is valid. All pair of requisites are unique. Okay. Okay, so I think I understand the problem now, limiting of some possible way. In here, I only get the sense that the if there is a cycle, then it is not possible to complete all the courses. If there is a conflict in the requirement, but I cannot think of any other example where we cannot complete all the courses. Let me think for the moment. Because for example one, it's just a direct dot and then we end at the end. So the first one is true, but the second one there is a cycle. And to detect a cycle, I think it's kind of not easy. How about I just here are 200 characters? Oh, alright. So I think I got in some idea. So because there are only 2000 corpses, then I kind of can do a VFS. And then if somehow when I follow along the VFS, I encounter a specific corpse, then it means that there is a cycle there. Which also means that I cannot complete all the courses. So I think that makes sense to do. For example 1, we have 1 pointing to 0. So what we could do is we have on 1, and then we found that there is 0 there. Okay, another thing to take care of is that one concept be could be a prerequisite of many courses. Yeah, so one course could point to many. So it doesn't say here that a course could be a prerequisite to many courses, but I think that is in fact. So we will jot it down in our findings, also as an assumption. Finding or assumption. Call the column of names. and course would have requirements. Like one idea to know where to start from is that once we build, I think let me jot it down in our step. So step one, we can build the graph. Second, we go to BFS on all. I mean on all the courses. Yeah. If at some point if we visit it twice, then there is a cycle. Um, so I think another thing that I have noticed is that we cannot do BFS. I mean, we can actually if we do BFS on a course, because this is many to many, then it does make sense that we will visit a node twice or more than twice even. Okay, so we cannot just simply do a BFS. There are further things that we need to handle. Okay, so let me cross out the point number 3 there because it is not right. So what else can we do here? Okay, how about I try out some more example. So let's say I have 0, 1, 2, then this 0, 1, then there is 2, and then there is 3 and 4. So in here obviously there is no, it is possible to complete it. But if we add one, say from 4 to 1, then it is not possible to complete our courses. So how do I know that there is a course that point to its own prerequisite? Then basically I need to know if it is in front of it. So is this a topological sort? I think there's something called topological sort. Let me check out real quick. Yeah, so this is something called topological sort. So how am I going to do this? Basically, let's see, let me think for a moment. A prerequisite of a course has to be done before we can take the course. So before we can take 2, we need to take 0 and 1. So I guess we need to know the courses at the beginning of everything. Then let's see. I cannot take course 3 because I haven't taken course 2. I haven't taken course 2 because I haven't taken course 0 and 1. So here I need to take course 0 and course 1. But how do I know that 0 does not have any prerequisite? So let's see. What I could do is that how about I just let's say if I take 2 and then take 3, how about I just take like a dual BFS as I said before, but then except that I need to check whether 2 is possible to complete. Okay, how about this? If I take 3, then there is no further courses that I need to complete because it is standalone. If I take 2, then I take 3 and 4, then it means that all of this, 2 is 2 can be completed, 3 can be completed, 2 can be completed because 3 and 4 can be completed. And then when I take course 0, I know that it can be completed because course 2 can be completed, course 1 can also be completed because course 2 can be completed. So if I look back to example 1, I know that 0 can be taken, 1 can also be taken as a result. If I look at example 2, I take course 1, then I need to take course 0. Then if I take course 0, I need to take course 1. And at that point there is a class because I have found a cycle. Alright, so I think what I need to do now is that I just need to do a BFS on all of the nodes. And by doing so, I will eventually find out which node has a cycle. Because consider in example 1, there is no cycle because I can take 0 and 1. I can take course 0, which has no cycle, and then I can take course 1, also because there is no cycle. But for example 2, when I take course 1, I can take course 0. I need to take an advanced class. So course 0, well then course 0 has an advanced class, which is course 1, but then I have visited it currently, so I just return false. And then for example 3, I could have take course 2 and then course 3, course 4, which means that 2, 3, 4 are all good. And also I can take course 0 and 1 because course 2 is good. If that is the case, how about we look at some more example? Let's say we have 4. Well, yeah, I think that anyway, if we do a BFS and then somehow there is a cycle, then at some point we are gonna find out sooner or later. Okay, so how about, let's see, we have 0.22, 2.23, but then 3 pointed to 0. In this case, when I take course 4, it's okay. When I take course 1, and then I move on to course 2. Course 2, I will take course 3 and 4. When I take course 3, I will take course 0. And then when I take course 0, I will take course 2, but then I find out that I have taken it before. I'm taking it currently, so it is part of the current cycle, then I just return false. Okay, I think I'm gonna create a class so that I can build a tree. So let me look at some its previous questions, how we are gonna create a class node. How about, let me look at okay. So I think I am pretty good about this. When I proceed to coding, the complexity would be ON because I will do a BFS on the whole graph. So that would take me ON to go through all the courses. Time complexity would be ON2 because I'm going to create ON or the number of nodes and nodes. Now I'm going to proceed to coding. I'm gonna create a class. I'm gonna call it node. Define init. Do I need to store the file? I think I don't need to do anything at this point. So how about I init it and then I create a self dot next initialize to empty list. How about I use a that? How to go through a that? Okay, let's just use a list then. for easiness. And then I'm gonna implement the function there, can finish. And we are given num courses and the prerequisite. So what I'm gonna do is I'm gonna create a dictionary of all the courses to have a mapping from a course number. Is it course number? Yeah, let's just call it course number, and then it will point to the node. So let me call it course initialize to default empty dict. Then I'm gonna go through all the prerequisites for so let's call it next, or let me think of a better name. Current and previous. Okay, current and previous in prerequisite. Then I'm gonna put it inside our course dictionary. If cur not in course, then I will initialize it into empty dict course of current equals node, and then same for the pref, not in course, course of cur, next, sorry, course of next, initialize to an empty node, and then I'm gonna append the cur, the pref dot next, the append the course of current. Okay. Then I'm gonna iterate through okay, how about this? So I need to check whether I am visiting a node or not in my current part. So I need a variable to tell me whether I am visiting or not. And also I need to a variable to see if the node have been checked or not. Okay. So let me define a variable called check, initialize to false, and then self.visit equals to false. Then I'm gonna create a BFS. So let's see. I'm gonna look through all the courses for I think I don't have to know the key. So just the so just the course then. So for Node in course dot values, I'm gonna do a VFS if not VFS of Node, then I'm gonna return false. Otherwise, if I have go through all the node, then I'm gonna return true. Alright, so now let's work on the BFS of node. So what we're gonna do, so if node.check, then I just return node.check. If I have checked it, then I just return true. Okay. Otherwise, I need to check if it does not. So what do I do here is, I think in Python there's something called all. Can I use it? All Python. Yeah, so Python has an all function. So let me try that. And here I'm gonna mark it as visiting. So node.visit node.visit is true. Then I will check if actually I just return it. Okay. Now I need to check. So if not all let's see. If not all of BFS, I think for the moment. So if not all of BFS, the next for next in node.next, then I'm gonna return false. Otherwise, I just set the visit to false back, then I return true. Okay, so I think this could work now. Um, okay, I forgot one thing. So after I visit it, I need to set the check as true so that this save up for the computation in the future. Okay. Now let me quickly check the code again to make sure I don't miss anything. I have a node class, and the next is a list of all the pointers to the next node. And then I'm gonna create a variable called check. This is to make sure I don't check the node multiple times. And then there's a visit node to indicate whether currently I have visited the node or not. For the initialization, I'm gonna use a course dictionary. If it is not in dictionary, and then I create an empty node, then I add the next course into one of the prerequisites using the prerequisite list. Then I'm gonna check for all BFS node or for all node whether they have any cycle in it or not. Then in the BFS, I'm gonna see if I have checked it. If I have checked it, then I just return true. If not, then I mark it as visiting, and then I'm gonna check for all the next courses to see if it is good or not. So if not all are good, hold on, I forgot to use the visit. So let's see. Okay, so after the if here, I'm gonna check if not.visit, then I need to return false. Okay. Otherwise, I set it to visit and then go through all the courses for the next courses. I'm gonna check, and then if there is a loop, I'm gonna find out at this point. This will return false, and then the not all will become true, and then we have our answer, which is false. So I think this could work. Now let me quickly go through our example again. Example 1, we have 0, 1. So let's say we check in 0. It is not checked. It is not visited. Then we mark it as visited. What happens when Python has an empty list? What is the return of all? So let me check Python all. Okay, so if it is empty, all will return true. So we are good to use all. Then in this case, it will return true. Then we mark this as not visited, and then Sorry, the visit should be false. Actually, okay, I got it wrong here. So not.visit becomes false, but not.check becomes true. Okay. And then when I go to check node 1, I haven't checked it, I haven't visited. And then the next, I'm gonna see that 0 is 0 can be completed. So I return true. Then in the end, all are good. So I return true. Alright, so I think this could work. Now let's go to the example 2. I'm gonna check course 1, which is not checked, and then I mark it as visiting. And then for all check, I'm gonna check again. So 1 has a next of 0. So when I go to 0, I see that I am visiting it. Then I return false. So result 1 will also be false. And in the end, I'm gonna return false. Okay, so I think we are good. Now let me quickly put our code into LeetCode. So class node define init. Then there is a cell here. Did I do it wrong? Define init. I think init doesn't have a self there. Actually, yes, it's not define init self. Yeah, but I'm not sure why the tab is not working here. It should give me an auto tab. Oh, sorry, it's not the deal, it's a define. And then self.next equals empty list. Self.check equals false. Self.visit equals false. Then in the check, I'm gonna create a course dictionary for curve in prerequisite. If curve not in course, I'm gonna create the course. Then same for the path. Now course dot path dot next dot pen course occurring. And then I need the BFS function, so define BFS on the node. Actually, I should have called it DFS. So if not dot check, then I return true. If not dot physics, return false. Otherwise, if not all, dfs max, or I think I call it let's see. I think I cannot use a next. Is it a reserve name? Let me check. Is next reserved in Python? No, next is not reserved, so we can use it. If not, dfs of next. Or next in node.next. Then I'm gonna return false. And first of all, before I do this, I'm gonna set the physics to true. Actually, I could just save this into node.check. And then I'm gonna return node.check. Alright. Now here at the end, I'm gonna return all of the course in the course dictionary. So let me call it node, or is it df? Okay, dfs. Node or node in course.values. Alright, so let me try to run this. Course, that one was given. Okay, self. I forgot the self there. Yep, I got this right, and this is false. Let me try to submit it. We got it right, but it's actually pretty slow, surprisingly. And the memory usage is very large compared to others. Let's look at some other solution there. You can finish adjacency list open v in degree plus q. Okay, so this is using just a list. So we do that. How about I try to implement my logic using this similar adjacency list? Okay, I think let's do that. So let me comment out this all. Then we create a new solution. Okay, so here what we can do is we could use a adjacency list. I think. Okay, I think I will keep the course dictionary. Right. But then instead of using a class, I'm gonna create an empty list. Is it in the, yeah, let's do it this way. So cross.pref, I'll just directly append it. Or should I use the tag? Okay, let's try with the tag then. Okay. And then here the DFS, I'm gonna replace it with a for loop. Okay, let's do it by a while course. And then let's pop it one by one. Python dictionary pop. Is there anything like that? Yep, there is a Python pop. Can I just pop any element? Python dictionary pop any. If you need to remove an arbitrary item, you can use pop item. Is there something like that? Let's check. You can pop item. Yep, so you can use pop item. Alright, so let's pop item. So net equals course dot pop item. So this would be prep. And then let's see, prep and curve. Okay. Now what do we need here? So we need our checklist. So check checklist and set. I think can we use a set? Okay, we don't need a chat, but we need a visit. Sorry about that. So visit, what do we need to use here? Then you can use a set. Okay, let's use a set then. Okay, we call it a checklist. So checklist set, and then we add the current. Okay, so curl is a tag. So now can I add multiple items into Python? Actually, let's just do this. Okay, so while check, then while Python loop to get curl equals. So this one should be put outside. We inside have an curl check dot add the curl. Okay. Now while there is check, we pop one out. So check actually we could just look through all the check then. So check is the check is a get in. So if a node is not in the course, then it is good. But it has to be outside of the visiting. So visit is to start with empty. And then I add the check to current. check the append the current. Actually, this should be just inside. Yeah. And then check the append curve. Visit the add track. Okay, now while check, we're gonna pop one up. So let's see. If we pop one up, then we check all of them, add to list, and then add to check again and again. So while check, pop, then let's call it let's just call it item equals check the top. Okay, and then what we're gonna do is we look through all the items. So for actually let's just go through it all at once. So for next in check.top, we're gonna see if next is in the visited. If next in visit, then just return false. Okay, otherwise, I traverse the child. Okay, now I might add visit.add next. So how do I know that there is a pointing to a visited node if I haven't checked it? Actually, I think we should just look through the codes then. So for curve, for prep, curve in calls the item, what you're gonna do is you don't want to pop it out yet. but we can do so at the end. So course.pop. In this case, actually, I need to use a while then. So course, and then pop item. Can I pop a key? Second dictionary pop key. Get random key. Okay, let's just solve it. Okay, let's use a while, and then correct is keys on 0, and then visit. We add the prep, and then check not append. We append. How do I append multiple items at a time? Python append multiple items to that. So I can use extend. Okay, so check dot extend. Was this is next. Next in course of prep. Okay. Then we'll check. I'm gonna check on pended, and then so on and so on until I have checked all of them. So for while check, check dot pop. Now the curve becomes check dot pop. Then if I visit it already, then the curve in visit, then it just become false. Otherwise, if curve is still in the course, then I'm gonna add the next one that I need to check. So that will be expand cause the current. Yeah. So this one should be current for clarity. Expand next. Before I go to the next thing to check, I need to add it to visit. So visit dot add could be end. If I finish this loop, that means I have found that it is possible to complete it. Okay, let me try to run this. Okay. Can I just not using anything? Yeah. Close the keys. So I need to create a list. Time limit exceeded. How is that possible? Okay, I forgot to pop out. So if I have checked that it is good, then I need to pop it up. Actually, let me just use good. But then, very efficiently do everything. Okay, I can use the physics outside. So physics, I put it outside. Then here, I'm gonna look to throw in key in the course. Yeah. Then I need to check if code in physics. Then I just continue. Okay. I don't need to pop this out anymore. So if for current course, current visit continue. Otherwise, I visited. Can you see if I have checked it? Hold on. So how do I differentiate between I'm checking it and I have visited it? So I need a finish set. So I finish set empty set. So what is the difference between finish? Finish means that I have checked it. Alright, so I think I got it. So visit has to be inside the for loop. So here, if I see that it is good, finish, then I just continue. Otherwise, we need to check. At the end, I'm gonna add it to finish. Is that what? So here, when you check if curve in finish, then I just continue with other things that I need to do. Here, finish.add visit. Python add set to set. Okay, so I can just update. Finish curve set.top. How come check.top is a dead? Check. Something is fundamentally wrong about my understanding. Hold on. So course of curve. What is the course of curve? Source of code is an empty stack. It's a stack of empty lists. How come? Do I print a constant? I see, here I'm appending the wrong thing. Sorry about that. Yep. Wrong answer. This method true. I return false. So what went wrong? Somehow something is in the vicinity. Okay, let me just rename something here. So this is check. If I have checked it, then I edit to check. Otherwise, I'm gonna add it to our to-do. To-do.pub. Current.add. We do visit.current. If current in course, then to do the extend or the next one to check. Funny that we got this test case wrong, but I can identify it. This is check. Okay, let's print the code. Actually, in here I just add to-do.add the code. Yeah, let's do this. Then, yep, give that a pen. Now it becomes wrong. How is that possible? So 1, and then somehow curl. Okay, so curl a pen. Okay, so we haven't visited it yet. Alright, now let's see what we got here. So it's 70, 70. How come it is printed twice? In curves, like 42. Okay, so here this way. Right. 70 to 69. 786. So it did visit it. So it does visit the same thing. But how come it doesn't mark it as wrong? Fine. Let's print the cross. So we are checking 70, 786. 70. 7t has bit confusing. How about we print? Okay, anyway, so let me put it into our text editor. 7t 546 265 737. Okay, so next it check the 265 and then 265 we have 603 and 737. So check 737. 737 is empty, and then we check 603. Finally 786. Actually, let me just print out in the code. So for key in backtick in key, comma process in. Okay, okay, in course. Okay, there we go. So when it checks 70 until 149, and then let's see what it got here. 786. So 327, that is 786. But then in the end, when we check 149, so 786 is supposed to be the end. Yep. But then because we have checked it, then it doesn't mean that. Alright, so I think I got the problem here. Okay, I got it. It's your design problem, definitely. So what we can do here, if we have specific it, then turns out it is the end. Actually, we should not have. Okay, so if there is nothing to append, then we don't need to create it. So that's the easy solution. Yep. Okay, I think this should work. Try that out. Still, we got the wrong answer. So let's check this. Eight, 5, 1. Okay, we did visit 851 twice. Alright, so I think our solution here without a note is kind of messed up. Yeah, our usage of physics is kind of flawed. 851 because 851 point to an end. So how do we know that we have visited a set if we are using DFS? We get rid of the DFS if we get rid of the visit, then it will go through that node over and over again. So I just got an insight. How about we just reverse it and then yeah. So do I need to even reverse it because it's the same? Hmm. Let me think for a moment. Because if we have visited a set, if we have visited that node, then at that point, so if all the charts are good, then it itself is good. Hmm. So we kind of have to do it from the top to bottom. But we cannot know the top and bottom at all. The prerequisite of everything. So that means the first course that we need to take. Okay, let's look at our accepted solution. So basically, I just need to turn this into an iterative solution, but kind of it feels so hard. I think okay, sorry, it takes a bit long time here, but just let me think for a moment. So if we have a to do, then we extend it. At some point, okay, so we need to update the chat earlier than something like this. How are we going to do that? There is no way to tell. There is no way to tell other than checking the root. But what if the root, what if the child is not checked yet? So the issue here is that I need to check the child, but then I cannot know if it is okay without checking it. Okay, so I think I got an idea. So somehow I need to use a different approach here. Basically, I use the course and then I pop it one by one. Once that is empty, then it is good. So okay, let's think through this carefully. if I pop an item from 1, so if we look at example 3 in my paper, when we check 3, okay, I think we just stop here and then I will start it in another video. So we do that. Okay, let me just stay here. Okay, let's stop here because this is like a second attempt. Thank you everyone.